Hey, feeling good, like I should. When in dark, walk around the neighborhood, feeling blessed.
All right, let's take a look at our homework for lesson 2.2.4. Starting off with our M&Ms for adding integers. First off, let's make sure we understand what we're talking about when we're talking about integers. As we discussed in our in one of our previous class settings, integers include all whole numbers plus their opposites. So a lot of times when you think of integers, you think of the positive and negative numbers on the number line, not including any of the fractions or decimals. And so sometimes people think that 0 should be left off and 0 isn't an integer, but technically it is, because 0 is one of the whole numbers. And if you take all of the opposites of whole numbers, 0 technically doesn't have an opposite, but 1 is an opposite of -1, 2 as an opposite of -2, and 3 as an opposite of -3. So every whole number has an opposite, and that entire set of whole numbers with their opposites makes up the set of integers. And so one of the big lessons we've learned about how to manipulate those integers is when we find 0 pairs. So 0 pair is what you get when you add a positive to a negative. So if you're thinking of Cecil on the tightrope or a number line kind of a process, if you add 1, then you immediately go back and subtract 1. That's considered a 0 pair. So this entire process right there gets you a net of 0. When we're working with integer tiles, anytime you add opposites to each other, they always have a sum of 0. So the basic 0 pair is the positive and the negative being added together. So, excuse me, this representation with integer tiles is just a variation on the Cecil tightrope kind of a problem, where when you add a plus to a minus, that's a positive one, that's a negative one. Together, they cancel each other out to make 0. All right, so let's take a look. I'm going to put my little screen down here. Find the value of each of the following expressions. All right, so let's do this. So this is a multiplication problem. So it's 3 times 4. If you were to expand it out, it's literally telling you to take the number 4 and add it repeatedly 3 times, and that's how you get 12 for an answer. Here you've just got, looks like we've got a 0 pair there, so it's going to end up being 11. Here you're going to have, rather than saying 3.2 twos being added together, you can kind of do the reverse order and say 3.2 plus 3.2. So instead of having 3.2 twos, you say you have 2 3.2s, and that's what we've got there for 6.4. This process right here is 3 negative 2s is -6, but because you have the absolute value bars, remember the absolute value tells you how far a number is away from 0 on the number line. So -6 is 6 units away from 0, so that's why the answer to this problem is 6, not -6. We're asking for the absolute value of -6. And here you double 7.5, you get 15. So if you double -7.5, -7.5 plus -7.5 gives you -15, but we're taking the absolute value of that, so it would be +15. And then here, same idea. What we're starting to pick up on now is when you multiply a positive number times a negative number, you get a negative answer. So when the signs are different, you get a negative answer. So what is 5 times 10 and 1/5? Well, I guess you could add 5 10s together to give you 50, and another 5 1/5. So 1/5, 2/5, 3/5, 4/5, 5/5 would be equal to 1. So this total has to be -51. Problem number 80. When or use the distributive property to write each of the following products as sums and then calculate the value. All right, so when you're using the distributive property, you got to multiply the 9 times 410, but it might be easier to write it as 9 times 400 and then 9 times 10, because these are easier to solve mentally, right? 9 times 4 is 36. So 9 times 400 would be 3,600 or 3,600. And 9 times 10 is 90, so now we can add those together to get our overall total, which would be, I guess I never wrote it in, did I? 3,690. And in this case, 6 times 592 would be 6 times 500, which is 3,000. 6 times, actually, let me do it down here. This is better to do it here. Then you do the 6 times the 90, which would be 540, and then 6 times 2, which is 12. So by the time you add all those together, our grand total ends up being 3,552. Now for the diamond problems, remember, the diamond problems tell you you multiply the two numbers on the sides, and the product goes on the top, and you add the two numbers on the sides, and their sum goes on the bottom. So with that in mind, 9 plus something equals 16. So you think, all right, well, what's 16 minus 9? That's 7, right? So this number has to be 7, and now you can multiply 9 times 7 to give you 63. What do you add to 8 to give you 15? That would be 7, so 7 times 8 is 56. And now this problem is the one where this is modeling, I'm going to show you right here, a problem where you might say, all right, let's take x squared plus 14x plus 49, and we have to factor this polynomial, which you don't know even what I'm talking about, but you know you're going to get x times x. And so we ask this question, what two numbers can you multiply together to give you 49 that when added gives you 14? So these diamond problems are setting you up for this type of math when you get to high school. And as it turns out, the two numbers that you multiply together to give you 49 would be 7 and 7, and when you add them together, you get 14. So when you factor out this polynomial, you get this variable expression. Enough of that. And then here, we've got the two numbers on the side, so you just add them together, and you could have written this as 2.5 instead of 2.5. And then what's half of 2? It's 1, and so that's how you get that answer. Problem number 82, making sure we fully understand how to go back and forth between decimals, percents, and fractions. So the decimal number has the same name as the fraction. So this says 45 hundredths because the 5 terminates in the hundredths place. So we would write that here as a fraction, but that fraction isn't in simplest form. But it does help for converting to a decimal, or I'm sorry, to a percent. So 45 hundredths by rule is 45%. And then you just need to find what are you going to divide the top and the bottom by. Turns out they're both divisible by 5. So 45 divided by 5 is 9, and 100 divided by 5 is 20. So 9/20 is the simplified fraction for 45% and 45 hundredths. And then same idea here, 127 over 100 would mean, if you're going to change that to a decimal, that the 7 must be in the hundredths place. And so you just write the entire number with the 7 in the hundredths place, means the decimal needs to go there. And if you think about the value of this number, 127 over 100 is an improper fraction. So it's more than 1, but it's not more than 2 because that isn't 200. It's not more than 200. It's between 100 and 200. So you know your decimal answer has to be somewhere between 1 and 2. So that also helps you put the decimal in the right location. All right, Camille had a very fun birthday party with lots of friends and family attending. The party lasted for 3 hours. I'm going to highlight that. She and her friends played games for 3/8 of the time. So, you know, coming up with a way of drawing a diagram here where you break these up into equal portions. So, like, here's the halfway point. Here's a halfway point. And then find the halfway point between both of those, like that. So now we've got 8 equal parts, right? So playing games is 1, 2, 3 equal parts. So I'm going to highlight that in yellow. And ate pizza for half the time. Oh, pizza and cake for half the time. So let me take half of this, and that's pizza and cake. So the remainder of the time was for opening presents. You can kind of see right there, this section right in there, these were broken up into 8 equal parts, so that has to be 1/8. So 3/8 plus 1/2 is 3/8 plus 4/8, which is the same as 7/8, which means the open presents indeed is 1/8 of the time. So 1/8 of the time, how much time were they there? They were there for 3 hours, remember? So we want to figure out what is 1/8 of 3 hours. You can convert it to minutes if you want to. Or you could just take 1/8 of 3 would be 3/8, and 3/8 in decimal form is 375 thousandths. But I don't want to, I mean, who knows what that is for hours? It's just easier to convert it to minutes, right? Everyone knows what 22.5 minutes is, but not everybody would know how much of an hour that is. So probably better to just change the 3 hours to a number of minutes, 180 minutes, and then take 1/8 of that. And what is 1/8 of 180? Let's just prove that with the calculator. 180 divided by 8 is 22.5. So there you go. And then our last problem. Ooh, God, you guys had some good work today. Jana measured the heights of sunflowers growing in her backyards, and here are the heights. So it looks like we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 different heights. So you're going to have to use your calculator and add all those numbers together and divide by 16, and you get a mean of 65. If you want to find the median, you then have to put everything in order from least to greatest. So let me go ahead and do that. I'll do it over here. So what's the lowest number on here? 34. Then we've got a 39. Actually, let me go ahead and pause so this doesn't take too much time. And when I come back, I'll have them all ordered. All right, we got them all in. So now, since I counted 16 original pieces of data here, I want to make sure after I put them in order that I've got all 16 accounted for. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Got it. So what number falls in the middle? Turns out there's going to be 2 of them in the middle. Half of 16 is 8. So let's count over 8. 1, 2, 3, 4, 5, 6, 7, 8. And from this direction, 1, 2, 3, 4, 5, 6, 7, 8. Well, it's kind of nice that both of those numbers in the middle are the same number, so we know that the median is 61. I don't really want to add all those together and prove to you that 65 is the mean, but if you need me to do that, I'd be happy to do that. All right, then it says create a histogram to represent this data. Your histogram should have 4 bins, each with a width of 15. So if we have 4 of them, 15 plus 15 plus 15 plus 15 is 60, right? So I guess we need to start at 30 because there's no reason to go below 30 because our lowest number was 34. And the highest number is 88. And if we count by 15s from 30, that goes 15, 45, 60, 75, and 90, then yeah, we can accommodate all of these in this section here. So what we need to do is we need to figure out, all right, how many of these numbers are in the 30 to 45 range? Looks like there's only 2 of them. How many of them are in the 45 to 60 range? Looks like there's 3 of them. How many are in the 60 to 75 range? You got 4 of them. And how many fall in the 75 to 90 range? Looks like there's 1, 2, 3, 4, 5, 6, 7. So we've got our frequencies. The first, this section right here has to go up to 2. Let me actually change that color there because that's looking a little confusing. This number has to go to 2. This one had to go to 3. This one had to go to 4. And what did we say was the last one? Total of 7 of them. And let's add all those numbers together. 5 and 4 make 9, and 9 and 7 make 16. So there you go. So this is an example of a histogram. Remember, histograms are different from bar graphs because bar graphs have the bars separated because you've got categorical data on the bottom. This is numerical data, so we don't want to use a bar graph for this. We're going to use a histogram that references a number line on the x-axis. And so there shouldn't be any gaps in there. Every number is accounted for in one of those bars, and in one of those bins. All right, there's your homework for 2.2.4. Now let's get headed to today's lesson, which actually, maybe we're not doing a lesson. Maybe we're going to do an assessment. We'll check. All right, so take care. Bye.
Hey, feeling good, like I should. When in dark, walk